Hi, welcome to this course. My name is Dmitro, and in this course I'm going to cover the main concepts behind Next.js. First, I will talk about what Next.js is and its primary features. Then I'm going to explain these concepts while building a simple example app. We will set up a Next.js project and add TypeScript. Then we will set up and run a local MySQL server for the app using Docker Compose. Next, I will talk about routing and styling in Next.js. Then we will set up a database connection in the app and build an API route for getting a list of posts using Next.js API routes feature. Then we will create a few more API routes. Next, I will show how to render pages using various methods such as static site generation, server-side rendering, and client-side rendering. Then we will add a form for creating posts. Finally, I will briefly talk about Next.js config and how to add metadata to pages. So, this is the plan. Let's get started. Next.js is a React framework for building web applications. It's very popular at the moment and it's used in tens of thousands of websites and web applications. It provides essential features that are required by modern web applications such as static site generation, server-side rendering, flexible file system-based routing, built-in feature for building API endpoints, automatic code splitting, built-in CSS support, and much more. So let's have a look at the big picture of how a Next.js application works. Next.js includes two parts: client-side and server-side. Client-side is responsible for rendering pages in a browser and other front-end functionality like client-side routing. And on the server side, Next.js allows us to pre-render pages, and this includes fetching the data required to render a page. A basic user flow would look something like this. A user visits a page and Next.js prepares HTML for that page, and in the process it can fetch some data from some backend API. This can be a headless CMS like Strapi, Contentful, Prismic, or a custom API, or even Next.js built-in API routes feature. So Next.js gets the data, prepares the HTML, and it renders it for the user on the client side. As we saw earlier, Next.js works on both the client side and the server side. When the user requests a page for the first time, Next.js handles this request on the server and responds with the initial HTML. On the client side, Next.js makes this HTML interactive. And from here, Next.js can handle page transitions in the browser, so we can switch between pages without reloading the whole browser tab. Next.js includes functionality for building backend API, the built-in API routes feature. Basically, you can build both the front end and the back end for an app using Next.js. Where Next.js really shines is the front end. It allows you to pre-render your pages both statically, in other words, using static site generation, and dynamically, using server-side rendering. And you can decide whether to use static site generation or server-side rendering for each page. Static site generation is when Next.js pre-renders a page just once at build time and serves the pre-rendered HTML to the users. So a developer runs the Next's build script and Next.js generates HTML for a page at build time. Here it also fetches the necessary data. Then a developer deploys the app and the users, when they request a statically generated page, Next.js serves the HTML it prepared up front at the build time, so it doesn't have to server-side render anything. Also, there is a really cool feature called incremental static generation. This is when Next.js generates HTML for a page at runtime based on some condition and reuses this HTML on each subsequent request. Now let's talk a little about server-side rendering. This is when Next.js fetches data and generates a page dynamically on the server side every time a user visits a page. And along with both static site generation and server-side rendering, you can client-side render a part of a page. It's when a pre-rendered page is served to a browser, it can still fetch some data and render it. Moreover, you can statically generate the whole app and serve it from a CDN. But because in this scenario you won't run Next.js on a Node.js server, you won't be able to use features that require Node.js. For example, incremental static generation and some other features will not be available. So, in this short course, I will explain different concepts and features of Next.js while building a simple app. On the main page, we will list blog posts from a database. For the database, we'll use MySQL, and when the user clicks on a post title, we will fetch and render that post. Also, we will add a form for creating posts. So let's get started and learn more about Next.js. Let's go ahead and set up a Next.js project. To get started, let's open the docs, Getting Started, and there are a few ways to set up a project. We can use a script or set it up manually. Before Next.js released this setup script, I used to set up my projects manually. So if you are completely new to Next.js, I would recommend doing the manual setup once to get familiar with the basic structure of the app. In this video, I will use the script. I will use the Yarn version. You should run this script in a folder where you would like to store your projects folder. Here we should enter the project name. Let's call it My Next App. This script creates a folder for the project using the project's name. Inside of this folder, it initializes the basic file structure and installs the dependencies. Inside of this folder, you can run the following commands: yarn dev to start the development server, yarn build to build the app for production, and yarn start to run the app you have built using the build command in production mode. Now let's go ahead and open the app in VS Code. I will open the terminal and run the app in development mode. This starts the development server on localhost port 3000. We can open it in the browser. At the moment, our app has only one page, the home page. This page is located in the pages folder in the file index.js. Now let's have a look at what the installation script prepared for us. Let's open package.json. Scroll to dependencies. The script installed Next framework, React, and React DOM. We've got the pages directory. This is where we store our pages. The home page is in index.js. And to add another page, we simply create a file in this folder. We can also create subfolders. Now let's create the about page. A page file should export by default a page component. This should be a React component. Let's render the title and visit this page. We can visit a page by typing the file name here without the extension, like this. And here it is. Okay, there are a few more interesting things in the pages folder. This is the API folder. Next.js allows us to create a backend for our app. It has a feature called API routes, and we can store these API routes in the API folder. For now, we have one API route called hello. It exports a function by default. This function takes the request and response objects. Inside of this function, we can do something like read from the database and send a response. In this case, it's JSON. Let's call this API route. We can call it by typing here in the path API/hello, the name of the file, and here it is. Another interesting thing is this file _app.js. Next.js wraps all pages in a component called app, and it allows us to override this app component. And in order to override it, we create a file _app.js and create the app component ourselves. This component has been overridden initially to import global style sheet on each page. We've got a public directory. Next.js can serve static files from this directory, and we can reference these files in our pages using relative paths. Like for example, to access favicon icon in index.js, we type the path like this. Basically, we type the file name relative to the public folder. Another interesting folder we've got is called .next. This folder is created by Next.js during the build step. .next is the folder where Next.js stores the files it compiles during the build process. Usually you wouldn't want to look inside of this folder, and this folder together with node modules shouldn't reach the repository. Let's have a look. We've got some warning here. Let's check it out. Next informs us that anonymous arrow functions cause faster fresh to not preserve local component state, and it asks us to name our page function. So let's name it about.js. Let's move it out here. Let's call it about and export it by default. Okay, this is fixed. Also, the install script initializes Git for us and creates the first commit. Okay, we have set up a basic Next.js app. Now let's go ahead and set up TypeScript. Next.js supports TypeScript almost out of the box. So to start using TypeScript with Next.js, we need to do just a few simple steps. The first one is to search for TypeScript in the docs. Okay, to enable TypeScript, we should add the ts.config.json to our project. We should leave it empty. Next.js will fill it in when we restart the dev server. So Next.js did not fill it in, so let's check why. And it says the following: we need to add TypeScript and the types for React and Node. So let's do it. Okay, let's run the dev server again. And our ts.config is complete. I recommend to enable the strict option. Enabling this option, we make sure that we follow best practices in our TypeScript code, so the code is more type safe. Also, Next.js added a file called next.config.js. It references various Next.js typings. Basically, this file tells the TypeScript compiler to include these typings while compiling our code. This line includes the default type definitions from the Next package, and this line includes the type definitions that are stored in the types/global DTS file in the Next package. We can even click into it to check it out. Here it is. So this is the type definitions that are stored in Next. So it's node modules, Next, types, global DTS. I'll close it. So basically, this file makes sure that the compiler knows about the Next environment while compiling our code that uses Next API. The final step is to change the extensions of our JS files. So let's change them. React components should have the extension tsx. This extension informs the editor and the compiler that this file contains JSX syntax. Same for the about component, app component. Hello.js is not a component, so it should have .ts extension, since it doesn't have any JSX. Okay, I'll save the file. Let's see, there is an error. Let's try to restart the dev server. Okay, looks like the app is working. Now let's do one more thing related to setting up TypeScript. Now let's tell the editor to use for type checking the version of TypeScript we installed in the project, instead of using its own version. For this, let's enable the status bar. I will open the settings, go to JSON mode, and here status bar visible, I'll set it to true, and open some TypeScript file. And now I can click on the TypeScript version that VS Code uses and select TypeScript version and use workspace version. This creates a folder.vs code with the settings that VS Code should apply to current workspace. Finally, let's fix the types in app component. Let's describe this props using app props. Let's import them. Okay, we should also describe this route handler here. Let's describe the rec object. I think the type is next API request. Okay, and response is next API response. Okay, now let's check if the app still works. The route, okay, it works. Now let's visit the index page, and it works as well. Now I would like to talk about routing in more detail. Routes are defined by the file structure in the pages folder. Every file in the pages folder that is outside of the API folder and excluding the components we override is considered to be a page. A page file should export a React component. The path to the page file starting from the pages folder is mapped to the route which serves it. Index here is a special name that is mapped to the base of the route. For example, let's create a subfolder here. Let's call it products and create an index page in here. Let's call it products. And export it by default. Okay, now we can visit this page using the route /products, like this. Okay. Almost in any web app, we need to render something based on some URL parameter, and the Next.js allows us to define such parameters using file names as well. In Next.js, routes with dynamic parameters are called dynamic routes. Let's say we've got some products and we would like to show them by category. And I would like to view that category by visiting the following path, products category. To accomplish this, I will create a file in the products folder, and it will have a special name, which includes the name of the parameter in square brackets. Let's call the parameter category and .tsx. This tells Next to store the category value in the category parameter. We will be able to access the category value using this parameter. Okay, let's create the page. And render the category in the title. To get the parameter here, we should use next router. And to get the next router in the page component, we should use the use router hook. So let's go ahead and import this hook. It's exported from next/router module. Now let's get the router. Okay. Finally, we can get the parameter. To get the parameter, we should read it as a property of the query object from the router. And the name is the parameter we used here. Okay, let's export the page by default. Okay, let's check it out. So I say products/category, or let's call it some category. And here it is. Okay, we have learned how to create pages. Now, because we are building a modern web application, we need to allow the user to navigate between these pages without the reloading effect we usually see when we click a usual A tag. On the homepage, let's create a link to the products page. In a simple HTML website, I would do it like this. Okay, let's remove the code that has been added by the installer. All right. Let's go to the home page. This is our link. I'll click on it. You might have noticed that the transition was not smooth. Let's check it out again. I click on the link and you should look here. Here you see it's loading. The browser requests the whole page from the server every time. What I'd like to accomplish is a client-side transition. This means that the Next.js will fetch from the server only the parts that are necessary to render the page. It will not request all the HTML and JavaScript required to render the whole app initially, and therefore the transition between pages will look smooth. So to enable the client-side transitions, we should use the Next.js link component instead of a simple A tag. Let's go ahead and import the link component. We should wrap the A tag in this component and move the href prop to the link here. Okay, let's check it out. I'll click on products and the transition is smooth now. We've got one dynamic page. To create a link to a page that uses a dynamic URL parameter, we should add one more prop to the link component. To demonstrate this, I will create a link to the products category page. Okay, let's turn this into a list. I'll copy and paste this link here, rename it to products. Let's just name it some product category. And this should link to, we might think something like this, some product category. If you specify the path like this, the transition won't work, because Next doesn't know that we are trying to get to a page with a dynamic URL parameter. So to create a link to a dynamic page properly, we should in href prop specify the original path, including the name of the parameter like this, and then specify the actual path using the as parameter. And here we can pass the category name. Okay. Next.js provides another way to interact with the router. It's the router object. We used this object already in the category page here. So to get the router, we should use the useRouter hook. We can use this router object to get various data related to the current route, like for example the current path, and for navigating the user. For example, if the user signs in, we could redirect them to a dashboard page using the method called router.push. For example, here I can create a button and on click, I'll redirect the user to the home page using the router API like this. So push and the path. Now let's say home page here. Let's open the... Okay, if I reload the page. Oh, I should visit the category page. Okay, some product category. Here's the homepage link. If I click on it, I'll get to the homepage. Together with pages, we can create API routes. Each file in the folder pages/API becomes an API endpoint that is mapped to a URL path that starts with the API here. Okay, I will open one endpoint, and to handle a request, we should export by default a function which takes two arguments, the request and response objects. Next also supports dynamic parameters in the API routes. Basically, to generate API routes, you should follow the same file naming rules that are used for pages. Next.js is very flexible as to the options it provides for styling our application. Out of the box, Next.js includes the CSS in JS library called Untitled.js. It allows us to write both global CSS and the CSS that is scoped to a particular component. So first, let me show you an example of using styled JSX. Let's write some CSS that will be scoped to the homepage component. For this, we will use the style tag with JSX prop enabled. Okay, somewhere in the container, let's add the style JSX here. Inside of this tag, we can write CSS as usual. For example, let's style the main tag here, this one. Let's change its background to green. During the build time, style.jsx processes the CSS inside of this tag and scopes the selectors to the current component. Let's check how it works. Okay, the main element is green. Let's inspect it. As we can see here, styled.jsx generated a class name that is specific to the homepage component. And this class name is added to the element that matches our selector from the style.jsx tag, this selector. Here, main should be green. And style.jsx appended this specific class to our selector to make it so this CSS is applied only to the main tag inside of the home page component. So during the build time, style.jsx processes the CSS inside of this style.jsx tag and scopes the selectors to the current component. We can write global CSS using style.jsx as well. For this, we should add another prop here to the style tag, and this prop is called global. The CSS inside of the global tag won't be scoped to any particular component and will be applied globally. So in this example, all main elements will have the background green. Here, if I reload the page, here, this is our global selector now. The homepage's class name was not appended to our selector. Styled.jsx is not the only option for styling a Next.js application. Next.js has a built-in support for global CSS imports, CSS modules, and Sass. Let's have a look at global CSS imports. The installation script generated some global CSS for us and stored it in the styles folder. Here it is. And this global CSS file is imported in the app component. Next.js wraps every page in this component. So the styles we import here will be included on each page. We can import global CSS like this only in the custom app component. We cannot import global CSS files in pages or other components. To style other components, we can use CSS modules. For example, let's style the menu that we have on the homepage for now. First, I will move this menu out to its own component. Okay, let's create the components folder. This is a common practice to store other components that are not pages in the components folder. Let's create the menu component here. Let's use a function component. Also in Next.js apps, we can remove React imports from our component files because Next.js uses a Babel plugin that will auto-import React for us. Okay, I will paste the menu here. Let's import the link. Let's render the menu back on the home page. Okay, now I will create a CSS module to style the menu. Next.js requires us to include the module suffix in the CSS module's names. This is a convention that Next.js uses to recognize CSS module imports. Okay, let's import this CSS module. Let's add some CSS. I prepared some CSS up front, so I will just copy and paste it. Okay, let's add the menu class to the menu container, this UL tag. Okay, let's check how it looks. The menu became horizontal. Also, let's remove the green background. In Next.js, almost out of the box, we can use Sass both in global CSS and in CSS modules. To use Sass, we should install the package called Sass. So let's just go ahead and do it. Yarn add Sass. To use Sass, we should change the extension of the CSS imports from CSS to SCSS or Sass. I'm used to SCSS, so I'll change it here to SCSS. Okay, and here as well. Let's check if Sass was enabled. Let's add a variable here, border, and apply the border here to the menu container. I should start the app. And here's our border. Let's add some padding as well. Okay. Finally, let's add a layout component to share common layout styles between pages. Okay, I'll create layout component here. Okay, let's wrap the child components into a div. TypeScript doesn't recognize the children prop. For it to recognize it, we should describe layout as React component. We'll use a function component type. Let's add CSS. Okay, and apply the container class to the layout div. Okay, let's wrap our pages in this component. Let's start from the home page. We will wrap the whole page here. Okay, we don't need this. We don't need the other styles that were there initially. Let's remove them. Okay. Let's remove the footer and move the menu to the layout component. Okay, let's wrap children into main tag now. Okay, I'll go back to the index page and add some title. Okay, let's have a look. Something wrong. Can't resolve this module. Okay, I used wrong extension. It should be SCSS in the import. Okay, here it is. Now let's apply the layout component to other pages. Okay. And the product category too. Let's import it. Okay. Okay, let's have a look how it works. I'll visit products, same layout, product category, same layout as well. Perfect. Let's go back to homepage. Wonderful. I discussed styled JSX, global CSS imports, and CSS modules because these options are built in. You can use other CSS setups as well, like for example Tailwind or styled components, but they will require additional configuration. Before working on the front end, I would like to get the API ready, so we have some endpoints to read and update the data. However, to be able to create the API, I need to set up a database. And for our example, I have chosen MySQL, because it's a well-known database and the basic SQL language is easy to understand. So let's go ahead and configure the database. First of all, I would like to create a schema. For this, I'd like to prepare an SQL script. Let's store it in the folder called db. I'll call the file schema.sql. First, let's create the database. Let's call it blog. Let's tell MySQL to use this database for the commands that follow. Let's create a table for posts. A post has an ID, integer, unsigned. Let's auto-increment it. Title, varchar 255. Not null. Not null means the following. When we add a row to this table, we won't be able to set title to null. In case of the title, we will have to set it to a string. A post has content. It's text, not null. And let's set the primary key to ID. Okay, our app will have a single table. Finally, let's insert some test data. I will just copy the insert code here. This will insert a test post to our table. Now we should set up a MySQL server for development. I would like to use Docker to host a local server, in particular the Docker Compose tool. To be able to create and run Docker containers on your computer, you need to install Docker Desktop. This is what I use. To install, please download the relevant package to your operating system and follow the instructions inside of the installer. If you would like to learn more what Docker is, you can either visit their documentation or look for a good tutorial or video about Docker. Docker Compose allows us to define and manage our Docker containers using a YAML file. The file is called Docker Compose YAML. Let's create it in the root of our project. I prepared the code up front as well. I will copy it here. Okay, here I tell Docker Compose to create a MySQL container. I called it MySQL in the scope of this file. You can use any other name for this container, like database, for example. The container should be created from the official MySQL image. Here we tell MySQL server to use for default authentication plugin MySQL native password. From version 8, MySQL started using a new authentication plugin. But many libraries that connect to MySQL do not support this new plugin. So here we say that we would like to use an old plugin for authentication. Then we have this option. If this container stops for some reason, like an error occurs, this tells Docker to restart it. However, if it stopped the container manually, it won't be restarted. Then we define various environment variables, and in particular MySQL root password, and the credentials we would like to use to connect and query the database. MySQL server will create the development user with development password, and it will also create database blog for us. Further, with the ports option, we say the following. We would like to forward local port 3306 to the port 3306 in the container, so we can access this database server from our localhost port 3306. To create this file, I used the information from the documentation of the official MySQL Docker image on Docker Hub. Here. Okay, here. This is the docs. Here we have an example of a Docker Compose file. I used it as a starting point. Now let's go ahead and start our database container. To start the container, let's run Docker Compose up. Okay, the thing here is that Docker Compose occupied the terminal, so let's run our container in the background. For this, I will use Docker Compose up d, detached. Okay, let's check the name of the container. For this, we can use Docker Compose ps. This command lists all the containers started by Docker Compose, and this is our database container's name. Now that we started our local database server, let's import the schema. For this, I will use docker exec command to run MySQL command to import the schema inside of the container. Let's enable the I option, interactive. This allows us to stream the data from our schema file to the command that we run in the container. Then we should specify the name of the container. Okay, and the command. We will run the command using sh c, then run MySQL with user root password. Let's use the env variable we created earlier here. Next, we should specify the database where we would like to import our data. Okay, and then stream the contents of our schema file. This ran our SQL script successfully. There were no errors, only a warning using a password on the command line interface can be insecure, and this is because we used the password option here in the command string, but we used an env variable here instead of an actual password, so I would say it's pretty secure because we don't expose the actual password. Now, in order to connect and query the database from our API endpoints, we should install and use a package called serverless MySQL. Later on, I plan to deploy this example using Vercel, and Vercel deploys the API endpoints from a Next.js project to serverless functions. So serverless MySQL wraps the MySQL client package, providing connection management for the serverless environment. So let's go ahead and add serverless MySQL package. Now let's create a connection and test it. Let's open the page's API hello.ts and import the serverless MySQL here. Now let's set up an object that we will use to interact with the database. Here we should set the database credentials. I will store the credentials in environment variables, and to access environment variables in Node, we will use process env. And we need MySQL host, then the database, the user. Also, I have noticed that TypeScript doesn't recognize these properties on the env object, so let's describe these properties to TypeScript. For this, we need to do declaration merging. Basically, we need to merge the declarations of these properties into the env object. For this, let's check how env object is declared. Here's the env object's type definition. It's defined using the process env interface. Let's click into it as well and check where it belongs. And it belongs to the global Node.js namespace. So let's use declaration merging to declare our custom env variables on the process env interface. For this, let's create our custom type definitions file. Let's call it custom.d.ts. And in this file, let's declare Node.js namespace as well. And our own process env interface. And inside of this interface, we can declare our custom env variables. Let's copy them from Docker Compose. Okay. All of them are strings. Now let's go back to our API route handler and declare the last credential variable, and it's the password. And now TypeScript gives us a hint of what properties are available, and let's choose password. Okay. Now let's fetch the posts from the database and serve them to the client. In order to use await in our handler, let's make the handler asynchronous. Okay, let's select all posts. Now we should call db end It's asynchronous as well. And return the posts here as JSON. Okay, we have set up a database connection here by reading the credentials from the environment variables. But the thing is that we need to import these environment variables into the app somehow. And Next.js has a mechanism to do this. And to set the environment variables, we can use various .env files. For example, we can create a .env file to store only the environment variables for the local development, or we can create an env file to store the variables for production, etc. Because I plan to deploy this project to Vercel, I will configure the env variables for production using Vercel's API. So let's use the Next.js feature for storing env variables in the file system only for local development. And for this, we will use the .env.local file. Here I see that while practicing the tutorial, I already created this file. Here it is. I have set the local development environment variables here, and I added one more variable, and this is the API host URL that we will use on the client side to query the API. You might have noticed that I added a prefix here called next public. This tells Next.js that it is safe to use this env variable in the client-side code, because by default Next.js doesn't allow us to use env variables in client-side code for security reasons, so we don't expose our secrets. Okay, let's check if this works. Okay, let's visit the API route. And here's our post. We were able to fetch it from the database. Now let's extract the database connection code and store it in a separate module to be able to reuse it. Let's create a folder called lib. It is a common practice to store common code in lib folder in Next.js projects. Let's call the database connection file db. I'll close node modules and export db by default. Okay, let's import it in the route handler. It's two folders up, lib, db. Let's try it. And it still works. Now what should we do if we stop working on this project? First of all, we should stop the Next server. And since we started our database container, we should stop it as well. And for this, we can run docker compose stop. This stops our local MySQL server container. Now that you stopped the container, you can run it again by typing docker compose upd. You can also remove your container completely using docker compose down command. This removes the container and the network created using docker compose. Also, it's important to note that using docker compose down removes the data that you store in this container as well. So you will lose your MySQL database data. So if you don't want to remove the data, you can just stop the container and resume it later. We created an API route that returns a list of posts. Now let's go ahead and create a few more routes, one for creating posts and another one for getting a post by ID. I will use the same path for creating and listing posts. In Next.js, a route handler function is called for all HTTP methods. It will be called not only if you request a route using HTTP GET method, but also post, put, delete, and others. So when the user sends a GET request, we should respond with a list of all posts. But when the user sends a post request, we should create a post. To check the requests method, we can use rec.method. So if it is a GET request, we return a list of posts. Otherwise, if it is a post request, Let's create the post. First, we need to accept the input from the user. For the input, we will accept a JSON object with title and content of the post. In the handler function, we can access this object using the rec.body property. TypeScript doesn't know about the structure of our input object, so we need to describe it to TypeScript. Our input object has title and content. Now let's create the post. We are using a prepared query here to escape the input, so we list the values using question marks, which will be replaced with the title and the content from the input object. Escaped. So the MySQL package will escape this input before merging it into this query. Now let's call the serverless MySQL cleanup function. This function does connection management related to the serverless environment. Finally, let's respond with the created post. Let's respond with 200. Let's get the ID of the post we have just inserted. It's available as the insert ID property of the result object. DB query returns result as unknown. So let's describe this result object ourselves. I researched the result object already, and I learned that the type of this object is OK packet from the MySQL package. So let's import MySQL here. We didn't install this package directly in our project, but it is installed as part of the serverless MySQL. And now from MySQL, we can use the following type here as a generic type parameter to the query function. The type is called OKPacket. And now TypeScript knows about the structure of the result object, and it knows it has the insert ID property. Now let's return the other properties. Okay, now let's test it using curl. Let's specify the content type. We are sending a JSON object, so it's application JSON. Then the type of the request is post. Then we should pass the data. And the API URL. Failed to connect to localhost port 3000. Oh, it's because I didn't launch the server. So let me copy my command. Okay, launch the server. Okay, and run the command in another terminal window. Okay, internal server error. Let's check it. Here it is. Table blog post doesn't exist. Okay, I know what happened. I dropped my MySQL server container using the docker compose down command, and then I started a new container using docker compose up and did not import the schema. So I'll do it. I have this command in memory. It's docker exec. Here it is. All right. Now let's run the curl command. Oops. I stopped the dev server, so I'll start it again. Then let's go back to another terminal window and run the curl command again. And this is the response. We've created another post, which got an ID too. Now let's create an endpoint for getting a post by ID. To get a post, we should request the following endpoint, posts/post ID. So let's create a route for it. So we create a folder posts. It's a dynamic route. Here we should capture the ID from the URL. Okay. The handler structure is similar to posts handler, so I'll just copy it and paste it here. I will remove unnecessary parts. Okay. We still need the DB, but now it's 3 folders up. Okay, we don't need MySQL anymore. So let's go ahead and get that post. We can get the ID from the rec query object. Now let's query the post that has this ID. Again, let's use a prepared query to avoid SQL injections. And call the cleanup function. So now this query will return an array of posts. And since we queried by ID and the ID is unique, this array will have only one post if it is found. So we need to get that post from this array. First, let's check if the post array has something. Again, TypeScript doesn't know what posts is because the query method returns unknown. So let's describe the return array to TypeScript. It returns the following: title, content, and ID, and it's an array of these objects. Okay, so if a post was found, then we should return it. Otherwise, let's return a 404. Okay, let's try it. Let's get the post with ID 1. This is our first post, and here it is. Finally, our ultra simple API is ready. So let's start working on the front end and list all the available posts on the homepage. Now I would like to show a few options for rendering a page. By default, Next.js pre-renders pages using static generation. Next.js generates the HTML for the page during build time and reuses this HTML on each request. Our homepage is a simple React component. Let's remove this unnecessary import. Okay. There is no additional data fetching functionality. So Next.js pre-renders this page during the build process by default. However, frequently we need to fetch some data to render a page. Therefore, Next.js provides a mechanism for fetching data during static generation. And to fetch data during static generation, we can use the getStaticProps function. In this function, we fetch the data for the page, and Next.js passes this data further to the page component through props. So let's render the latest posts on the homepage and use this function to fetch them at build time. We should export this function together with the page component. We should add the data we want to pass to the props object. Let's try fetching posts using our API endpoint, this one. I'll use fetch. Fetch returns a response object. Let's extract the data from this object. Okay, because TypeScript cannot infer anything about the data fetched from the API, here REST JSON returns any. we should describe this data here. To describe this data, let's create an interface to describe a post. Okay, and use this interface here to say that REST.json in this case returns an array of posts. Finally, let's return the posts we fetched in the props object. Now let's get the posts from props and render them. Again, TypeScript doesn't know about the props of the home page. Let's describe them. Next.js provides a type that allows us to infer the type of the props returned by the getStaticProps function. And this type is called infer getStaticProps type. This one. It takes the type of the getStaticProps function as a generic type parameter. Okay. Let's list the posts. Okay, let's have a look at the app. Cannot read property map of undefined. I'll try to reload the page. Okay, it works. This is our list. This list shows oldest posts first, but because we say that we list latest posts here, let's change the order to show the latest posts first. I'll open the route handler here and add order by clause, saying to order by ID in descending order. And the latest posts show up first. At the moment, this page is pre-rendered using static generation. Let's make a little experiment to see that this page is statically rendered. Let's render a timestamp on this page. If we refresh this page, the timestamp shouldn't change. So let's go ahead and add the timestamp. Okay, home page. Let's add timestamp here. Okay, let's check it. On the client side, we will see the latest version of the timestamp if we reload the page. But in the HTML code that is served by the Next server, the timestamp shouldn't change. So let's view the sources here. Timestamp. Here it is. Let's reload the page. And we can notice that the timestamp changes. So we can't really notice the result of the static generation because we are in development mode. We are using the Next.js dev server, which rebuilds the page every time we reload it anyway. So let's have a look at what happens if we try to build our app for production. I'll stop the app, run yarn build. This calls next build. And we've got an error. Here it is. Request to our API endpoint failed. And this happens because at build time, our API endpoints are not started. To fix this error, we should fetch the posts directly from the database in our getStaticProps function, instead of querying an API. You might think that it's not a good idea to mix backend code with client-side code. It seems really insecure. However, from the Next.js perspective, it should be okay if we use the server-side code in this function, because Next.js removes this function and the imports that are used exclusively by this function from the client-side bundle. This is mentioned in the Next.js documentation. Here, if I open the docs, scroll a little down, and here we've got a note. You can import modules in top-level scope for use in getStaticProps. Imports used in getStaticProps will not be bundled for the client side. As explained below, let's click on this link, and here we've got more explanation. Note that getStaticProps runs only on the server side. It will never be run on the client side, and it won't be included in JS bundle for the browser. And this means that you can write code such as direct database queries without them being sent to browsers. It also says that you should not fetch an API route from getStaticProps, and we should write the server-side code directly in this function. Also, there is a tool that you can use to check what Next.js eliminates from the client-side bundle. So let's go ahead and query the database from this function. First, let's open the posts endpoint. Actually, let's move it into the posts folder to make our code more organized and rename posts to index. So this route will be available at the same path, but now we store the code related to posts in the same folder. So in the posts handler, let's move the code for fetching posts into a function so we can share it between this API handler and the getStaticProps function. So I'll copy it and move it to the db.ts file. Okay, get all posts. Here we fetch the posts. Let's make this function asynchronous. Okay, let's return the posts. All right, let's use this function in the API handler here. Okay, and now we can use this function in the home page here in the getStaticProps function instead of a fetch request. Okay, there is an error in this file. This one. Okay, TypeScript doesn't recognize the posts prop, and this is because we did not describe the posts array that is returned from getAllPosts. Let's open this function definition here. TypeScript cannot infer on its own the type of the data returned by dbQuery function, so we have to specify it ourselves, and there is a generic type parameter for this. So it's an array of posts. Let's create the post type first. We already have it on the home page. Here it is. I will move it from here to the db file and use it here to describe the array of posts. Okay, now this function returns an array of posts using a promise. All right. Okay, no errors here anymore. Let's try to build the app again. And there is another error. Let's check it out. Here it is. Error serializing posts 0, returned from getStaticProps. So JavaScript fails to serialize this posts array, and in particular the objects that are inside of this array. It means that there is some property in these objects that is not serializable, that cannot be turned into a string. So let's make sure that the objects we return from getAllPosts are serializable. Okay. Here, where we return the posts array, we got directly from dbQuery. Let's map over the posts and pick only the serializable properties. And these are the only properties we need. Okay, let's build the app again. And it has been built successfully. Wonderful. Now let's start this app in production mode to check our little experiment. Okay, it starts on the same port here, 3000. Let's reload it. Let's look for our timestamp. Here it is. Let's reload the page to see if this timestamp remains the same. And it remains the same every time I refresh the page. So this page is pre-rendered using static site generation. Now let's talk about another option for pre-rendering pages. It's called server-side rendering. This is when Next.js generates HTML for a page on each request. Server-side rendering is useful when you need to render a page on the server side and the data that you render on that page is updated frequently. For the sake of example, let's create another version of the homepage which will be server-side rendered. I will copy the original one and rename it to home SSR. Let's call this function home too. Switching from SSG to SSR is quite simple. Instead of using getStaticProps to fetch data, we should use getServerSideProps. So let's rename this function to getServerSideProps. Now to infer the props in the component here, we should use another helper type. It's infer server-side props now, and type of get server-side props. Okay, this is it. Okay, let's check the timestamp to see if this page is rendered on the server side. Let's build the app again. And start it in production mode. Okay. Oh, I should open the home SSR page. Here it is. This is the timestamp. Let's reload it. And here, every time I reload the page, timestamp changes. So it's rendered on the server for each request. Finally, let's try client-side rendering. With this approach, we will serve initial HTML without data. We will start fetching the data once the initial HTML is displayed to the user. Basically, we will fetch and render the data on the client side. I will copy the home page again. This time I will call it home CSR. Let's rename this function to home3 and remove this get server side props function. We won't get posts from props anymore in the component. Let's remove these imports. Okay. So now in this component, we will use the useEffect hook to fetch the posts from the API. We need to store the posts somewhere, and let's store them in the local state. Let's quickly describe the type of the data that will be stored using this hook. Right now, TypeScript thinks it's undefined, so let's describe it as an array of posts. For this, let's move the post type we created earlier here in DB to a common types file. I'll create it in the root project folder. Okay, let's import it in DB. Okay, and use it on our new homepage. Here, useState takes a generic type parameter. This is how we describe the state value type. So it's an array of post. Now let's call the useEffect hook to register our callback here. Our callback should be called only once after initial render of the homepage. So let's add an empty dependency list so dependencies won't change from render to render. Here, let's create an async function to fetch the posts. Here, let's call fetch. This time, I would like to use an environment variable to specify the API URL. We have added this environment variable earlier in the env.local file. Here it is, next public API URL. Appending next public to an environment variable makes it available to use in the client-side code. So I'll copy and paste it. Actually, let's add it to the type definition of the env object, as we did with these variables earlier. Here it is. Okay. And we need to call the posts API endpoint. Now let's get the data from the response. Okay, let's tell TypeScript how this data looks. It's an array of posts. And let's call setPosts with this data. Okay, I'll call fetchPosts here. So this will fetch the posts after initial render and store them in the state. Now let's render the posts from the state here. Posts can be undefined, and when they are undefined, this means that they haven't been loaded yet. So let's check if posts not defined, render a loader. Otherwise, render the posts in a list. Okay, let's try this. I will rebuild the app again. Okay, let's start it in production mode. Okay, let's change this to CSR. This is our timestamp. This page is statically generated. Let's check this by reloading it. The timestamp shouldn't change. And it doesn't change. Also, we don't fetch the posts on the server now, so we see this loading text. Now let's run this page to see if it works correctly. Okay, here it is. This is our posts. This time we successfully fetched the posts and rendered them on the client. I have used fetch in this example, but I would like to mention that the team behind Next.js created a React hook specifically for fetching data on the client side. It's called SWR. It provides a lot of useful functionality for data fetching, such as caching, revalidation, refetching on interval, and more. It is distributed as a separate package. Please check it out. Now I'd like to create a page for viewing a post by ID. Let's serve this page from the path post/post-id. For this, I will create a dynamic route. I'll create a folder called post, and inside of this folder a file with the name ID in square brackets. This is the name of the parameter that I would like to use to access the ID. Let's create a simple page component. We can render this page using one of the three approaches that I have discussed earlier. I would like to use static site generation. Compared to pre-rendering blog posts on the homepage, we have a dynamic URL parameter here. And if we decide to pre-render this page using static generation, we have to tell Next.js which variations of this parameter it should pre-render. Basically, in this example, we need to tell Next.js which posts are there in the database so it can pre-render them. So let's start by exporting the getStaticProps function to fetch a post by ID. This time we need to get the ID parameter, and we can get it from the context object that Next.js passes as an argument here. To get the type definition of context object, we can describe the whole function using a type called getStaticProps here. So the context object has the following parameters: params, preview, and preview data. We can read the URL parameters using the params object. So let's extract the ID parameter. Params can be undefined, then ID. If we hover over the ID parameter, we can see that it can be either string, an array of strings, or undefined. So let's make sure it is a string. Okay, now we should fetch a post using this ID from the database. For this, let's extract the code that we use to fetch a post in the ID API route here into a function. Okay, this is the code. Okay. Instead of describing the type on the fly, let's use the existing post type. Let's get ID from the argument. So this query returns an array. So let's turn this array into a single post. Also, let's make sure that this object is serializable. Let's extract only the properties that are serializable from it. Okay, let's use this function in the API route here. Okay, ID is string or strings, but our function requires a number. So let's turn ID into a number. And check if the post is there, we return it. Otherwise, return 404. Okay, let's use this function on our single post page as well. Here. Let's turn this value into a number as well. And return the post here. Now let's render this post. Let's extract the props type. And render the post. Okay, let's check here what's... Okay, so TypeScript did not infer the post correctly. And it's because we used the getStaticProps function type to describe our function. And this type takes props as generic type parameter here. And if you don't specify the props using this type parameter, the props become this object or index signature, where each prop is any. So let's describe our props. Okay, now we've got an error because here we require the post to be defined, but in here the post can be undefined. So before returning this post, let's make sure it is defined. And since this function runs on the server at build time, let's just throw an error here if the post is undefined. Post with this ID was not found. Okay. Now let's finish rendering the post. Alright, now let's move to the home page and add links to the posts list so we can view the posts. We use the next link component. Okay. This link links to a dynamic route, so we have to first specify the original route path in href, like this, and we should specify the actual path using the as parameter. Okay, let's run the app and check it out. Visit the original homepage. Here is the list with links. I'll click on a link and there is an error. Get static path is required for dynamic SSG pages and is missing for our page. As I mentioned earlier, Next.js doesn't know anything about our posts. It can't take the posts on its own and pre-render a route for each post. we need to tell it which posts are there in the database so it can render them. And we can do this using the getStaticPath function, as long as we are using static site generation to pre-render a page. So let's go ahead and add this function to tell Next.js which posts it should pre-render. Here, our single post page. We can use getStaticPathType to describe it. It's an async function. Here, let's read the posts from the database and return an array of path objects that we would like Next.js to pre-render using getStaticProps. So for each post, we return a path object where we specify the parameters object, and we've got only one parameter, the ID. And we should also set the fallback option to false. Let's check what the error is. Property ID is incompatible with index signature. Type number is not assignable to type string. So Next.js expects a string for the properties here, and we pass it a number. So let's turn this number into a string. Okay, now Next.js knows which path it should pre-render. And if I visit the page again, I should see the post. Also, we can check what Next.js pre-rendered for our statically generated page by looking at the output of the next build command. Okay, and here. So for post/id, it pre-rendered two paths, post2 and post1. Also, let me quickly explain the fallback option. We use this option to tell Next.js what to do when the user requests a path that hasn't been pre-rendered. For example, we've got two posts, post1 and post2, and what happens if the user requests post/3? If we set this option to false, Next.js will show the 404 page. If we set the fallback option to true, Next.js will try to pre-render in production the paths that were not pre-rendered during the build process. So it will try to pre-render our path/post/3 in the runtime. And if it pre-renders it successfully, it will store it in cache and reuse it for subsequent requests. Now let's go ahead and create a form for creating posts. For the form, I will create a page in the top level. I'll call it create post. I will copy and paste the initial HTML here. Okay, let's import layout. Okay, this is a very simple form. It has two inputs, one for the title and one for the content. To simplify handling this form, I would like to use React Hook Form package. So I'll go ahead and add it. To use React Hook Forms API, I'll import the useForm hook from it. Now let's describe the type of the values in the form. Then use the useForm hook to get the React Hook Forms API. We will use the register function to keep track of the values of the inputs, and the handle submit function to assist us with handling the form submission. For TypeScript to know about the values we are handling using this form, let's describe the values using a generic type parameter of the useForm hook here. Okay. Now let's connect the inputs. Okay, and add the form submit handler. Here we pass our own handler, which should be asynchronous, since we will call the API here. As an argument, it takes the values object. Let's use the values to create the post. I'll use fetch to call the API. Let's specify the API URL. Since it will be a post request, we should add some additional options. The method. We should set the content type header to application JSON, because we will send a JSON string. And finally set the body to the values of the form stringified. Okay, now on successful submission of the form, let's redirect the user to the home page. For this, let's use Next router. And one more thing, let's add a link to this page on the home page below the list of posts. Let's use next link component. Okay, now let's run the app and check this out. Okay, we are on the home page. Let's click create a post, fill in title. Let's call it hello world, add some content and hit submit. And the post hasn't been created. Something went wrong. Let me check it out. Okay. Yeah, I see. I entered the wrong URL here. It should be posts. I don't know why I added public here. Probably I was looking at this word here. Okay, so let's try it out again. Create a post, some content, and hit submit. And this is our post. Now let's go ahead and add some metadata for the pages. I'll open the home page, and to add metadata to a page, we can use the next head component. It's imported from the next head module. Here we can add the page title, various links like the fav icon, page description, open graph tags, and other metadata. Basically, whatever we put inside of the head component is added to the head section of our document. Now let's go ahead and change the title of this page. And here it is. The contents inside of the head are cleared when a page is unmounted. Like for example, if we visit another page, like creating a post. Here, the title of the previous page is not there anymore. So the contents of the previous page's head section are replaced with the contents of the new page's head. Now I will just go ahead and add a title for each page. Okay, we've got the home page, then create post page. And the post page. Here we will use the post title. And let's visit the home page and let's open some post and the title changes. Next.js works well out of the box. However, there are times when you need to modify the Next server behavior or the build process for some need of your app that is not supported out of the box. Next.js allows you to configure some of its internals using a configuration file. Let's search for it in the docs. Here it is. It's called next.config.js. You should store this file in the project's root directory. From this file, you can either export a config object, like here, or a function that will return the config object. A function takes two arguments, the face and some options, like the default config. The phase is the current context in which the configuration is loaded. At this moment, there are 4 phases available. The export phase. This is when we use the static export option. The production build phase, when we build the app for production. Production server phase. I guess it's when we run the server in production mode. And development server phase, when we run the development server. So in this file, you can do various customizations, like for example, customizing a Webpack config, or defining some environment variables that you would like to use in your app. And there are many other settings. Please have a look at this documentation for more details. So we have reached the end of the course. I'm glad you watched it and hope you enjoyed it and learned something new. If you liked this course, please hit the like button and or subscribe to my channel. I will leave the link to the code in the description. Also, I'm planning to create another video about deploying this project in the near future. So, see you next time, have a great day.